Hi, welcome to product review by Watt Hour. In this video we're going to do the review of this WUZHI WZ5005 5 ampere 50 volts or 250 watt Buck Converter that can be controlled also via Wi-Fi of your phone Android device. I'm going to explain the module, how to use it with all the features and functions. I'm going to show you the minimum and maximum input voltage and minimum and maximum output voltage. Then I'm going to test it with the inputs of 6 volts, 12 volts, 15 volts, 24, 48 and 55 volts. All standard outputs will be tested with maximum of 5 ampere. From time to time I'm going to show you a thermal image to see which spot is getting hot the most. We're going to see also the output ripple voltage. I'm going to also try the Wi-Fi feature of this module. We are also going to charge lithium batteries. You can get the resources for this video by visiting our website watthour.ca. I bought this from this Hong Kong Feng Tai store from AliExpress. They're offering it in different versions from $35 Canadian to $41, and I got this Wi-Fi version, which is $41 plus some shipping to get it faster. They have USB version, which has this port that you can connect it to USB, or this 485 RS485 version. And if you search AliExpress for WZ5005, you will see that tons of other stores are selling the same product, so it's available everywhere. I will provide you the link to Amazon store if you want to purchase it from Amazon. Step-down converter, and also called Buck Converter, is a module that multiplies by a factor which is less than 1. So we receive an input voltage, it goes through this power electronic module, and we have an output voltage. For example, Vn, if we have 24 volts to this module fed in, and X is 0.5, or it's divided by 2, so we have 24, Vn is 24 and X is 0.5, we'll get 12 volts at the output. In this presentation I'm going to explain the WZ5005 5 ampere 250 watt Buck Converter. First I'm going to explain the module fully, then briefly I'm going to have a look at the components. After that I'm going to show you the settings and how to set output voltages and current. Then I'm going to demonstrate the input-output voltage in terms of minimum and a maximum. After that I'm going to display the accuracy of voltage and current and measure it. Then I'm going to demonstrate how to charge a lithium battery. After that I'm going to demonstrate how to control this device using mobile phone. Then I'm going to test the output ripple voltage, and I'm going to show you the switching frequency. Then I'm going to do the tests with the input 55 volts, output 5 volts, 12 volts, 15 volts, 18 volts, 24 volts, 36 volts and 50 volts. Then I'm going to change the input voltage to 30 volts and output 3.3 volts, 5 volts, 12 volts, 15 volts, 18 volts and 24 volts, and then input voltage of 12 volts and output of 3.3, 4.2 and 5 volts. And here are the main features. We have input voltage of 6 to 55 volts, and output voltage can be set from 10 millivolts to 50 volts. Output current can be set from 1 milliampere to 5 ampere, and total output power can be up to 250 watts. The system has constant voltage and also constant current, which is needed for charging battery and many other applications, and it has 45.7mm LCD display or 1.8 inch, and we have R485, Wi-Fi and USB communication that can be used with PC and Android, and this is optional. I'm going to demonstrate the Wi-Fi feature with Android in this video. And it has the following protections. We have over voltage protection. When you set it at certain voltage, it will never go above that. And then we have over current protection. You can set the current a certain value. Even if you try to set it, it will not go above that. And then under voltage protection will protect it against certain feature or charging battery or some devices that does not allow to go below certain value. It has that feature. And then we have over temperature protection, OTP, where above 80 degrees Celsius it will turn off. The time that it can be programmed to turn off is from 0 to 100 hours. The amount of energy that it can show is 9,999.99, so that's 10,000 watt hour and 10,000 ampere hour for the capacity. So energy capacity error is plus minus 2%, it says. Screen brightness can be set between 0 to 6, so 7 levels. We have to see the differential pressure, plus minus 0.5% plus 1 volts, what they refer to. This is the package. When you purchase it, it should be shipped like this. Let's just open it. And as you can see here, the model here, it says input voltage 6 volts to 55, and output is 0 to 50 volts, the current 0 to 5 ampere, and the power 0 to 250 watts. And this is the Wi-Fi module. For the first time, I'm getting something that is packed properly. So we have the Wi-Fi module. Nice. So properly packed, and we have nice banana clip with alligator. There is nothing else. And here is the module. This is the WUZHI WZ5005 module. From the component and the design, it shows it has been designed very well, and people who are doing this, they know what they are doing. So this is a very good quality device. From initial impression connector, they have 4mm connectors, and it also comes with this wire, very good quality wire with this insulated alligator clip. That's very nice. Length of this wire is 1 meter, and also you can put your wire underneath under this screws to tighten it. We have also holes here, so you can pass it through to secure it. The input terminal, this can be removed, and you can insert your wires in here and tighten them. The positive is on this side and the negative is on the other side. We have one input 15 ampere fuse at the input, and also we have 15 ampere fuse at the output. These are surface mount solder type. All the current to the output passes through these two 25 milliohm resistor in parallel, which makes a 12.5 milliohm value. The module can be installed on a panel, and this one I broke it purposely to have a look here because I was not able to open it. And very nice soft silicon type touch push buttons, and then rotary encoder where you can change values. With these you can select them. I'm going to show you all of those. And this also it has 4 memory with M1, M2, 3 and 4, which you can set your voltage and currents with one push button. You can just hold and go to the value, which makes it very easy to use. And here are the dimensions of the module. Now let's open this layer, remove this. Now let's remove this layer. First we need to remove this connector very easily. Now let me show you how we can set the main features of this. When I turn it on, it shows this logo on this screen. If I press this arrow, up and down, it changes. In this screen we'll see the voltage, the current, and the power. This power is the product of these two when you multiply them. But when you bring it down, it shows the capacity that has been consumed, ampere hour, and the energy, watt hour, and the time when it was turned on. And this is the only screen where you can see the input voltage, Vn, in here. And depending on the setting, either the output is on and off, which I'm going to show you. By default, in this case, it has been set to be turned on automatically. And if you turn it off, you press this button, the voltage will be discharged slowly and the output goes off. The voltage can be set with this. When you press it with this button, the highlight is there. You can rotate this rotary encoder to change it, or with the left and right arrow, you can go to change this last digit or maybe these other values. So right now it's 13 volts. When you're done, just press it again, it exits. The same way you can set the current, for example 1 ampere or maybe 2 ampere, press it and exit. So now the current is set to 2 ampere. With this one, P set, that's the protection set. When you press it, it says OVP, the over voltage protection, 50 volts. When you set this value, the output will not go beyond this value. Let's say you set it to 20 volts, exit. When you press it again, it comes to the next one. This is over current protection. With this one, you cannot set that current that you set here. For example, if I set this to 4 ampere, so now if I press this, this is exit. Now the voltage, the output voltage is 13 volts. Let's turn it on. So output is 13 volts. Now if I, for some reason, over voltage protection is 20. If I, for some reason, if I set that to 25 volts, you will see that we will get error when you turn it on. Let's say 23. Automatically, over voltage protection is turned on. So because of this, it turns off the output. So this OVP, over voltage protection. Now, if I make it 13 and exit and turn this on, it is okay now. Now, the same way over current protection. This is 4 ampere. And let's set the current to 4.54 and then go here 4.1. Now it is set. This is over current protection. The over current protection only works when you draw the current, it will protect it. So those are the main features. And if I press this menu, you will see this menu here. When you turn this on from here, by default you will see some menu. You might not see that. If I press this, you will see this. If your screen is not like that, the reason if your screen is like this, it is Chinese language. You see all of these are numbers. The only thing is not a number or something that you don't understand is this letter. So that is the language. And here, if you change it, that will be English all. And now if I press this, exit, everything will be English if I press the menu back. The screen to be displayed data. This data here you can see, or you can set it to waveform. If I press this, now it will be a waveform. We can see the voltage, we can see the current, the power as waveform on the screen. And these are the scale of the voltage. 10 volts, if you change it. For example, now the voltage, the output voltage is displayed, 13 volts is displayed like that. And this is, if you go on this side, you can set the current scale, but because I have no load, it doesn't show. And if I press this, from wave, get back to data, so now it shows data. On this screen, if I press this arrow up and down, it changes. In this screen, we'll see the voltage, the current, and the power. This power is the product of these two when you multiply them. We have here 4 memory presets, M1, M2, 3, and 4. So these are the preset value that you set. If I press and hold this, it changed, it went to M1, and as you can see, it automatically set the voltage to 5 volts, the current to 5 ampere, the power and everything. But in M1, now we can turn it on, and that's your setting. Let's go to M2 and press and hold this. Now M2 is 12 volts, it automatically turns off, and if I turn it on, you will see it sets 12 volts, and these are the current and voltage. So it's very handy for different application. For example, if you're working with 5 volts, always put this 12 volts in here, and different parameters. Let's go to M4. So that is 36 volts, another industry standard. And as you can see here, it shows low voltage protection because we set the output to 36 volts. And this is the input voltage is below this output. So if I press this, you will see the input is 30 volts, so we cannot get 36 volts. For that, this protection is turned on, and it is telling you that something is wrong, so you can pay attention. And now let's go to M3, press it and hold it. So in M3, now M3 is active here. We have 24 volts with a different current and voltage set. So these 4 are very handy. Now, if you press and hold this for longer period, this will be locked. When you see this lock, none of these buttons will work, and it stays like that. Unlock it, just press and hold this. We can set the output power to on. If I go to the right side, this means power on. If you set this to power off, when you disconnect the power, let me exit. If I disconnect it, let me disconnect the power and power it up. The output power is off because we set that in here by default off. Now let's go and change it to on and exit. Now if I connect it, automatically when it powers up, the output will be on. So the next option, call out, is off. And here, when you want to reset these values for the capacity, 0.33 ampere hour and 14.95 watt hour, and the time, I could not find any other option but to turn it off. And once you reboot it, you can go to the menu and see it is 0 except the time that is running. If you want to recalibrate the voltage and current, 0, it says Y or yes, just press OK, and it asks you again for confirmation. So if you want not to calibrate it, go left and right, otherwise. So it is now calibrated. Here it says resume, that is a factory default setting. If you want to go to the factory default setting, you can say yes, and everything will be defaulted. Now it is Chinese. We have to go back to this menu and change this to English, and also I don't like this beeper, so we can turn the beeper off. I tried to open this. It seems these 2 terminals that are here, somehow I was not able to remove it. Even I broke one of these from this area to see if I can push it, but I was not able to open it. So I don't know the trick how to open it. And here I'm going to explain the components. And now let's have a look at the components here. This is a fuse at this point, and also That is the output close to these two terminals, and this is another fuse. Let's have a look at both. And here the input fuse close to this input terminal. This is 15 ampere fuse, and the other one in here, that's also 15 ampere fuse. Let's have a look at this chip. And it is RU7570L. Here's the data sheet for RU7570L. It is N-channel MOSFET from RU chips, 70 ampere, 75 volts, and here are the pins. Let's have a look at this chip here. It seems it's some kind of converter with these inductors close to it. And that is XL7015E. And here is a data sheet for XL7015E. It is 800 milliampere, 80 volts DC to DC converter from XL Semi. Let's have a look at these two shunt resistors. These are the resistors that all current passes, and these are 25 milliohm. They are in parallel, so they become half, 12.5 milliohm resistors. So the voltage across this is measured with one op amp here, and it determines the current. Let's have a look at these three op amps, or whatever chip they are, close to the output terminal in here. So this is A332, and here is the data sheet for GS8 331 and 332. This is zero drift CMOS rail-to-rail op amp with RF filter at 350 kilohertz. And then let's have a look at the next one. So this is also the same 8332, and this one is NCA 6008A. And here is a data sheet for NCA 6008A. This is N-channel MOSFET 8 ampere. And let's have a look at this larger chip here. And as you can see, they have removed the model. And here we have two chips, 1 and 2, something that looks like this, but the screw for this is beneath this PCB, so I cannot remove it. And the rest is the control and microcontroller and other components that is needed for the module, and this is for communication. Let me start the test. The input voltage is shown here, and this is our input current. I've connected my mean power passing through this ammeter coming here, so we can also read the current and the voltage. The output is displayed in here, and we will see it in here. This is the electronic load DL3031, and these are the two terminals that from the circuit will be connected in here, and we will see the voltage here and the current. First, let's check the voltage that is displayed on this, and this is the most trusted device, so we will see the voltage. As you can see, it shows here now 13 volts on here, and that's what we read here. And input voltage is now 30 volts. Now let's see the input and output voltage, minimum and maximum. And as you can see here, I have set the output voltage to 13 volts, and we are reading the voltage in here. The input voltage is shown there. So input voltage is 15 volts, and we can set any voltage below this voltage, but not above that. Now let's check the input voltage, what it reads. First we will read input voltage. As you can see, it shows 30.6 and 30.62. That's very accurate. So 13 volts. So let's put this to maximum. So 55 volts. As you can see, the input voltage is now 55 volts, and it is set to 13 volts. The amount of current, as you can see, it seems this is turning on and off to save energy. So this is the input current. Now if I turn the output off, this is the current now, fluctuating. And if I turn it on, you can see that. So let me set the output voltage and we will read it in here. So now it's 1 volt, 17 millivolts deviation. Let's go to 10 volts. At 10 volts, we are reading 35 millivolts deviation. At 20, we are reading 67 millivolts deviation. 30, now 84 millivolts. At 40 volts, we are getting now 90 millivolts. So at 50, we are reading 94 or 88 millivolts. It is fluctuating, as you can see. And now let's change the input voltage so we can read what is the minimum. So that's 5 volts. Let's change this to 6 volts. Many people ask question, if I change the input voltage, what happens? So here, nothing happens as long as you don't go beyond too low below the value. So at 6 volts it turned off. So let's go 7.5. So I'm reducing it slowly to see exact value. So 6.7. Okay, 6.2. As you saw, around 6.2. So we have to have the input 1.2 or minimum 1.5 volts above this, or minimum of 6.8 volts. King 5 amperes with 5 volts. Now let's see how we can charge a lithium battery, and for that we need certain parameters. In this example, I'm going to have a look at Panasonic NCR 18650R lithium battery, and this is a Panasonic NCR 18650. As you can see, the rated capacity is 3200 milliampere hour. Minimum and maximum is also mentioned, and here is the charge voltage, 4.2 volts. The charge current is 1625 milliampere hour, and that is half of this value. And here it says that the temperature below 10 degrees Celsius charged at 0.25 C, which means quarter of the capacity. And again here, it has been mentioned here as 0.5 C when you charge it, 4.2 volts. So 0.5 C is half of the capacity. So these are the battery parameters that you need to know in order to charge the battery properly. We need to know the battery capacity. We need to know the maximum charge voltage. We need to know the maximum charge current. You must know these 3 parameters in order to charge the battery properly. And the battery capacity is measured in ampere hour. In this case, from the data sheet, we know that it is 3200 milliampere hour. And maximum charge voltage, this is a voltage that the battery can be charged safely until the battery is fully charged. And here is the charge voltage, 4.2 volts. In this case, it is 4.2 volts. And the maximum charge current is the amount of current that the battery can be charged safely until the battery is fully charged. We also get this from the data sheet. In this case, it is 0.5 C. C is the capacity of the battery. So 0.5 C means 0.5 times 3200, the capacity of the battery, and we get 1600 milliampere hour or lower. So that is rated for maximum for this battery. Now let's charge this battery NCR 18650 and let's set the voltage to 4.2 volts. We set the voltage and then let's set the current 1650. I set it to 1650 now, and now let's connect the positive to the positive and the negative to the negative. So this battery is currently drawing 300 milliampere. The amount of current that goes to the battery depends on the voltage. Let me show you the voltage of this battery. You see, this is fully charged. If I take another battery, it will take more current. So this is now 2.9. Now let's connect the terminals. And as you can see, we are drawing from the charger 1650 milliampere. And as you can see here, it says CC, the constant current. So this has brought the voltage down because the battery is taking more current. So the constant current is very important, that does not allow above this. When the current pours here and the battery is charged, when slowly it fills up, the voltage will increase, and when it reaches fully at the maximum capacity, the voltage will be 4.2 volts and the current will become 0. So that's where the battery is fully charged. And here is an example for the 4 cell. I've connected them in series, which means the positive is connected to the negative and the positive to the negative. So this is in series, and for 4 battery, 4 times 4.2, 16.8 volts. Voltage doesn't matter, I'm just showing you. Now let me connect the terminals. And as you can see, it goes with 1300. Because this is not fully charged, the voltage is very high, so it doesn't draw full 1650. And because this is in series, we set it the same way. When you put it in series, that's exact current. And when you put the batteries in parallel, then you can increase the amount of current higher. If you have 2 of these in parallel, then increase the amount of current to twice as much. I go to this screen. Here is the WUZHI.com website. I've used Chrome to translate it, but you can download files by going to the download page. And they have this one, it says CNC power. There is one, but here, this is the one that works is for us is this is the app, WUZHI Power. You can click and download it from this link. Your phone will give you warning that it might not be safe because you're not downloading it from the App Store. I downloaded it and installed it from here. Let's see how we can get connected. First, insert the Wi-Fi module. And then let's plug the power. As you can see, it just sparks. And now you will see this on the screen, and you will see this Wi-Fi config screen. Let's open the app. It says Wi-Fi is not connected, affirm. So here I'm turning the Wi-Fi on, and then opening the app. Now the app opened and you'll see that's blank. So make sure that you're connected to Wi-Fi. As you can see, I am connected. and go to this menu, and you will see an IP address of this device. This IP belongs to this machine, and then click network setting, and you will see that this is pushing the IP address in here. You see server IP error. Wait for it. Until you see the IP. When you see the IP address, after that you can touch next. In this screen, this is the most important part. I experimented a lot, and you need to remove the password, because when I put the password, it did not work. I spent so much time, and finally I tried to change my password to just numbers, and after that remove the password, and suddenly it worked. It seems this is not able to push the string, it says the password to the device. So I remove the password for this temporary tutorial for my separate router. So this is not my home router, this is just for my YouTube. So there is no password, and click confirm. And here I have to zoom in so you can see the screen. Pay attention. You will see quickly in here and in here. Waiting for a string. It takes a while. As you see, it has been connected, and here network completed. It shows SSID IP address 102 for this device, and click OK. Once you're done, it says confirm. I don't know why this screen is here, but you have to go back, and this is the screen, and from here click connect. As soon as you click connect, you will see the graph, and this device is under control because this is the power. So let's turn it off, and you can see it is turned off. Turn it on, it is turned on. And I zoomed in so you can see it, because these texts are very small. We can see only voltage, and we can see the current. I'm turning on my electronic load. So the voltage is shown as yellow, and this is the scale for the voltage. And on this side, this is the scale for the current, and depending on the amount of current, the scale will change. Now the app has connected, and here on this side we see the voltage, because this model can accept up to 50 volts, so we have here 52 in this scale. On this side we see the current maximum 5 ampere, because this module can supply up to 5 ampere only. Here we have this yellow for the voltage at any moment. This is the current and the power. Let me turn this on. To turn it on, we press this push button here, and this will turn on. As you can see, it was turned on, and here 25 volts 5 ampere, because my load is taking 5 ampere from here. And here we can see this yellow is the voltage. The voltage is 25 volts. Here you can see it, 24 volts, 25 volts in here. And this cyan or blue color that you see is 5 ampere in here, because this is 5.5 in this scale. And also you can see the power, but the power is not graphed here, because these two colors is displayed on the graph. Here the current is set to 2 ampere maximum. Let's change it. When I touch, this screen came. Let's remove it, and let's type 500 5, and then click OK. So now it's 5.00. There is no current, this 5 ampere, and it shows 5 ampere constant current. But you can scale this up if you want, and scale it down, or you can scale it like that, zoom in, and that's the maximum that you can zoom out horizontally. And this is the time that has passed, 148,150, that's seconds since we started it. So you can go with the previous value and see that the beginning at 0 what it was, and come to this side, and let me just change it to 3. I'm just playing with this so you can see the graph here. I made it 1 ampere, and then let me increase it to 3 and then increase it to 4, and we can zoom in like this. That's very handy, definitely. It has some glitches, but generally it is good. And if you want to save it, just click save, and it shows here that it has been saved perhaps. Yellow increases up to here. Let's go make it 50 volts. Now it is 50 volts, and that's the current. What problems we face if we remove it? So let's turn this off, and suddenly the voltage dropped everything, but I cannot turn it on because this is off. And let's remove this Wi-Fi module, and let's turn this on. You see, wait in configure, and click OK, no, and here it says break. I have to break and then connect slave address. Now it shows fake value, so this app doesn't know that Wi-Fi module is not even connected, but it shows that it is connected. This Wi-Fi functionality generally works. It has some glitches in terms of showing the value and scales and zooming in and out. Other than that, it's perfect because you can set the voltage and cut it, and also the capacity and energy shows. You see this one now shows watt hour, and if I go to this screen, as you can see, it shows here watt hour is 18. Now if I switch back to this by touching the connect, now we are connected, then this screen is gone, and here it shows in terms of watt hour, it shows 4,984 or 5,000 watt hour. That's incorrect. So the capacity is 111 hour, and as you can see it is increasing. That's also incorrect. The time, so these are incorrect. Perhaps just the power. So it shows the power, voltage and current. Pause energy if you want to pause it. Energy paused, and then clear. It clears everything. Now I have connected oscilloscope to the output, and we are going to have a look at the ripple at different current. I've set now the output to 50 volts and 5 ampere. As you can see, the ripple is about 84 millivolts, and as you can see, the switching frequency, the time 61.9 kilohertz or 62 kilohertz, and here at 1 ampere it is 23.8 millivolts. Now I set the output to 24 volts 5 ampere, and the ripple is now 75.2 millivolts. Now I set the current to 1 ampere at 24 volts. Let's have a look at the ripples, and the ripple is now 19.2 millivolts at 1 ampere. Output is now 12 volts 5 ampere, and the ripple is 84 millivolts, and frequency is 61.9 kilohertz. Now output is 5 volts 5 ampere. The ripple is now 91.2 millivolts, and frequency is the same, 61.9 kilohertz. Now I set output to 5 volts 1 ampere. Let's have a look at the ripples, and the ripple is 24. Input is 55 volts, output is 3.3 volts with 5 ampere. The input current is 374 milliampere, and here is the efficiency. Output is 5 volts at 5 ampere. Input current is 531 milliampere. So 25 watt is being dissipated from this power supply, and here is the efficiency. Now with 55 volts input, output is volts 5 ampere. Input current is 1.174 ampere. And here is the efficiency. Now output is 15 volts at 5 ampere. Input current is 1.45 ampere. And here is the efficiency. Now output is 18 volts. This is a charge voltage for some lithium batteries. Input current is 1.725 ampere at 55 volts. 90 watt is being dissipated, and here is the efficiency. Now output is 24 volts. As you can see, with 5 ampere, input current is 2.277 ampere at 55 volts. And here is the efficiency. Output is 36 volts, 5 ampere. With 55 volts, input is 3.377 ampere. And here is the efficiency. Now output is 50 volts, 5 ampere, and that is 250 watt, the maximum power that this can supply. Input current is 4.656 ampere at 55 volts. And here is the efficiency. And here now the output is 40 volts, 5 ampere, 190 watts is dissipated. And here is the thermal image. At this spot we are getting 42 degrees Celsius. Let me put the pen at this spot. So underneath, that's a chip pair, and here we are getting 244 watts from this. Now this is a thermal image after a while. Now it's 44 degrees Celsius at this spot, exactly at the edge in here, and that is where the chip is revealed. Now input is 30 volts, output is 3.3 volts at 5 ampere. Input current is 660 milliampere, and here is the efficiency. Now output is 4.2 volts for charge voltage of single lithium battery with 5 ampere. Input is 0.812 ampere at 30 volts, and here is the efficiency. With 5 ampere output, input current is 948 milliampere at 30 volts, and here is the efficiency. Now I set output to 8.2 volts. That's the charge voltage for 2 cell of lithium battery. Input current is 1.488 ampere at 30 volts, and here is the efficiency. Now output is 12 volts with 5 ampere. Input current is 2.131 ampere at 30 volts, and here is the efficiency. Now output is 15 volts at 5 ampere. Input current is 2.637 ampere at 30 volts, and here is the efficiency. Now output is 18 volts, the charge voltage for some lithium battery for devices, At 5 ampere, input current is 3.144 ampere at 30 volts. And here is the efficiency. Now output is 24 volts at 5 ampere. Input current is 4.158 ampere at 30 volts, 119.2 watts. And here is the efficiency. Now output is 3.3 volts, 5 ampere. Input voltage is 12 volts and current is 1.637 ampere. And here is the efficiency. Output is 4.2 volts at 5 ampere. The input current is 2.022 ampere at 12 volts. And here is the efficiency. Now output is 5 volts, 5 ampere, 25 watts. Input current is 2.367 ampere at 12 volts. And here is the efficiency. Now output is 8.4 volts, 5 ampere. That's a voltage for the 2-cell lithium battery. Input current is 3.83 ampere at 12 volts. And here is the efficiency. Now output is 9 volts, 5 ampere. Input current is 4.088 ampere at 12 volts. And here is the efficiency. I'm just testing it with input of 5 volts, see if it works. 3.3 volts, let's go with 5 ampere. As you can see, low voltage protection detected and it turned it off, so it will not work. Thank you for watching a video from Watt Hour. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos.